비디오 좀
예.
틀어주실래요? 업로드되어 있는 비디오. 수업하기 전에 지난번 비디오를 보여주시면 좋을 것 같아요.
아, 예.
항상. 네.
잠시만요.
사운드 공유도 누르셔야 되고요.
예.
네, 공유할 때. 보여주시고 비디오 지금 올려놓은 것도 좀. Right? And today I'll talk about goal of this class. That is how can I say? It is open but not well used now.
Okay.
Because of the infrastructure, you need a
예, 저번 수업 다 업데이트 되어 있습니다.
계속 틀어놓으세요.
아,
Port for service, and also you need some kind of trading. How can I say? Some danger. Something happens because it is a new. There is a danger. It can be. So that when it is happening, you should have a port to escape, right? Or
Okay.
rest. That kind of infrastructure, including communication and also services that can be supplied during operation. So you can say, I can say that the route is not well used.
Okay.
So this picture shows the already established route and traffic.
Okay. And do you know if there are projects like creating those ports?
Okay. Can you stop the video and stop sharing? Then we can start the class. Do you have any question from previous class? Any kind? No? Then we can start from the PPT of previous slide. So this is the schedule, and today we will cover today is 26th, Thursday, and we will cover the Naval architecture overview, and also I'll show you after break how to turn project for guidance for your project preparation. Right, and then this is the PowerPoint. We started on Tuesday, and we stopped here, page 5. So let me start again here. So basic definition of directions of the ship in terms of front part and back and left and right has their own name, special name. So
It is not easy to memorize, but once you memorize, then it's good to use for other cases, not only for ships. And port side is special. I guess airplane also used same terminology of port side. Okay, then next slide shows up also basic definitions of dimensions, size. So there is a 3 related definition regarding the height of the ship, draft and depth and freeboard. But they are related. So in the middle of the picture, there is a colored one and white one. Between them, the draft and freeboard is combined into depth of the hull. So here you can see the ship, and usually the bottom side of the ship is colored by this color. Many cases, most of the big ships have colored like this one. And above that red one, or purple, they use different colors. Sometimes, many times they use a black color. But anyway, that dividing line between purple and blue, that usually is the water line, where the ocean surface is located there. But you can imagine that, or calculate that, if the ship has heavier cargo. So let me say the example of oil carrier, crude oil carrier. In more specifically, crude oil is oil coming from the oil reservoir. So we call this oil, kind of oil, as a crude oil, and that is transported to, say, Korea importing all the oil from outside. Korea does not produce any oil, and mostly coming from Middle East, Kuwait, Saudi Arabia, UAE, and other, Iran. And those oils are transported by oil tanker, as the ship type, and crude oil is the oil they transport. And when they loading oil from, say, Saudi Arabia to South Korea, the ship is full of oil inside the tank, so that ship is heavy. You can imagine the cargo truck on the road with heavy loaded, full loaded, and sometimes the truck is empty. Similarly, the ship comes to Korea and unload all the crude oil, and then back to Saudi Arabia again. When return voyage, the ship is empty. The cargo tank is empty, actually. So that the line between red and blue can be changed. Right? So this time, there is only one line in the figure. So we saw this one is a full loaded case line. So that we come back to our picture here. There is a draft. Draft is submerged depth in general term. But there are many cases, right? Draft is changing depending on the cargo loaded situation. The oil tanker is simple because they transport oil between 2 points, loading and unloading, and loading and unloading. So empty and full and empty and full. But if you imagine the container ship, which carries containers. Well, usually containers ship is moving around the world and servicing to, say, more than 5 ports around the world, starting from, say, Tokyo to Busan, Shanghai, Singapore, and somewhere in Egypt and Mediterranean, or otherwise big ships go around the South Africa and go to the Rotterdam in Europe. Right? So at each port, some of the containers are loaded and some of the containers are unloaded and loaded to each stop. So that the draft change is very complex to each cases. Well, anyway, here you see only one clear line between colored surface here. We see this is a full loaded. So above then you cannot load cargoes. So limitation. So we call this draft as the design draft. And freeboard is for safety of the ship, because many owners and also pilots, captain, want to load more cargo than allowed limit because of the money. That happens many times in cargo trucks. I can say you may have the chance to see heavy loaded, overloaded cargo trucks on the road that can damage the road surface. And things happening similarly in cargo ships. The captain wants to carry more cargo than that is allowed. So that's why the painting color is important to watch and make sure that they have enough freeboard for the safety, because the high wave coming, right? And the depths of the hull, and it says up to depths of hull. There is no deck line. But you can see from here. Can somebody mute your mic? Right, thank you. Right. See, above the blue line, blue colored line, there is a white lines, white, but there is only some of the white in the front part, the bow part, and some of them in the stern part. In the middle, there is no white belt. Okay? So that you can imagine that the deck, upper deck, we say the upper deck is colored like green, dark green. They have a staggered height. The height in the bow is higher, and in the middle is low, the deck surface, the color green surface, and stern part is also higher. That is because of the waves and coming toward the ship and following. And that surface, the green colored surface, we call this upper deck. Upper deck. So in the middle part, upper deck is lowest. Up to them, we count this is a depth of the ship. Here, the upper surface of this ship, we call this is upper deck in the middle of the ship, the upper deck. So the depth of the hull is measured up to upper deck here. And draft and freeboard and depth is explained. And then we will see that in the character-wise draft, the vertical distance from the water level. Water level is in the middle between freeboard and draft, down to the lowest point of the ship's hull. So we call this is the bottom of the ship or bottom of the hull. And depth is a vertical distance from the uppermost continuous deck. So there is a deck, we say the upper deck, to the bottom of the hull at the midship. So midship is important because in front part and so bow part and stern part, the depth is higher. That's why at the midship we should measure the depth for design or typical official depth of the ship. And freeboard is allowance for safety. So minus, here is I'm saying minus. Question? Okay, clear? So next slide. So typical ship structure is very complicated like this one because it is made of steel plate, and you see from steel plate is made of four-sided flat. They manufactured in the steel company and transported into the shipyard, and then the shipyard person cut same size steel plate coming from steel company, and then they put them together, stitching them together to make a ship. So, and because ship is big, even though the steel plate has the thickness of say 20 millimeters, then that means 2 centimeters. It is very flexible because of the length of the ship is 100 meters. So they need more frames, we say frame. So in this here you say deck plating, frame, and bulkhead is a wall between the room and deck. There are many floors. We say floor is same as deck. As stanchion is a column in the buildings wise. In the building we call this is column, but here they are saying stanchion and strake, shear strake. There's a special name for this, and bilge strake, and also keel line. Keel line is a very basic in the middle line, but you can say bottom, and plating. And here in the right hand side you say hatch. You may heard about hatch cover, deck plating, and beams. Beam is a frame like this one, frame under the deck plate. So you see these steps of the deck beam is not the depth, thickness of the plate. Thickness of the plate is very small comparing to the ship size. This is a height of the deck frames or deck beams. There are so many complications. We'll see more. Do you have any question on this? But this is a sample drawing for how complex is the ship is made of steel plate. Weight is also a complicated one. So how many of you, I remember that about half of you can swim 20 meters, right? I remember this. And here is my question. When your body as a swimming, no action in middle of the sea, what is the expectation that your body is coming down to the bottom of the pool's side, or it is floating near the water surface? What is your expectation? Your body, when you do not do any action, no swimming, just stay calm. What is your expectation? Is going down to the bottom of the
Float.
swimming pool or floating near the surface? Yes. Answer.
Float.
Float.
Mhm. That depends on if you have a lot of air in your lungs or not.
Depending on. Okay.
When you are
Two,
breathing,
right?
if there's a lot of air in your lungs, you're floating. But if you like empty your lungs, well, you're going to sink, I think.
So there is two options, right? Any other
If you
option?
stand like this, you will sink, and if you lie like this, you will float.
Oh, another option. So
Yes.
vertically, then going down.
Yes.
But horizontally, it is floating.
It depends on the pose of the human.
So depending on the pose of the human. Right?
Yes.
So horizontal or vertical, right? Three options. Any other? So then we can vote on this three. So remaining person is 5. Right? What is your option? Choose. Please choose your answer. 강충구, what is your option? What is your selection? Number 1, number 2, number 3.
Number 2 is
Number 2.
similar with me, yeah.
And Guvision?
I prefer two. Number 2.
Number 2? 고창훈? 고창훈, what is your
Number 2.
number 2? 스브라뉴?
Yes.
You raised your answer was number 1. I can believe who was the
Me. I said float.
oh okay, you are the number 1. Then Felipe.
I think it's number 1. It will float.
Number 1? Number 1. Right. So when you have a swimming class to learn the swimming, there is several exercise of one of them for the beginners. In Korean, we say in terms of Korean language, 새우등뜨기. But I don't know in English. It's a shrimp-like position. You put your putting your leg onto the chest and then stay there. That kind of thing you may try when you have a swimming class, right? The answer is similar to 2, yes, option 2. So your whole body is almost similar to the weight, specific weight, we say. 비중 is specific weight. Comparing ratio comparing to the water weight, say specific weight, is about same. Human body specific weight is almost same. So that the air in the lung is important. For the positioning, when it is not easy. So we can start from a positioning like horizontal position initially by using some device and then let go off. Then because of the lung air, the food is going down first. So then when human body is like this one, starting from water surface and no action, then your foot, leg is going down in this way, So that if you have a breathing air full loaded, then your body should be in the upright position, head on top, probably. But usually, because of the lung, this portion is going to the water, usually. But not above the water, almost near the water, right? Same as iceberg. So we'll see more in the later stage. So remember that human body, the specific weight is almost the same as what, right? So I'm explaining because the ship has a similar cases. So, and weight calculation is a little bit complicated, not so high physics, high level physics, but weight balance is complicated because shape is big and complex. So let me say the light ship, dead weight, and displacement and payload. There are so many different names and definitions only for weight for ship. And the light ship is the empty ship, you can say. And you imagine that when the shipbuilding company produced the ship and then deliver it to the ship owner, then you can say that at that time that ship is an empty ship, and the weight of the ship at that time is, we can say, a light ship. You can expect similarly to the car. When you order your car, some later stage, say 1 week after, the car company deliver your new car to your home. At that time, the car is very new and nothing inside. Right? So we can say there is a lightweight of the car. And similarly, the ship is, we say, lightweight. And dead weight, let me start from displacement. So they are saying, total weight, which equals lightweight plus dead weight. So that you can, so displacement is a total weight, and dead weight is some kind of a cargo weight, you can say.